Today our group will present on important topic which is accident risk monitoring and mapping. In today's fast-moving and constantly changing world, accident can happen at any time, whether it's on the road, at work, and in everyday public spaces. Because of this, safety management need to go beyond reacting after something happens. It needs to be more smarter and more proactive. This project focuses on how we can monitor and map accident risk to better understand where accidents happen and why they happen. By using real data and mapping tools, especially geographic information system, or we call it as GIS, we can visualize accident pattern and identify high risk location, also known as hotspot. And the last one, this insight allows us to take early and informed action rather than waiting for serious incident to occur. In the end, the goal is simple: to help reduce accident and make people safer, especially in areas where the risks are higher.
Next is review of literature. There is 5 review of literature. One is assessing impact and cumulative risk in traffic accident. Second is GIS analysis on road accident and road safety. Third, identification of risk hotspot location using network kernel density. And the fourth one is optimizing kernel density estimation, bandwidth for road traffic accident hazard identification. And lastly, the case study of spatial and temporal analysis on road traffic accident using GIS. For the first one, the case study of roads incident risk in Romania, Balencico and Mann 2024 used map and method called AHB to study where road accidents happen in Romania. They found that most incident risks come from how serious the crash is, whether by weather and incident type also matter. Highways are safer than small roads. Their method helps find dangerous spot even when there isn't much data. The second case study is in Malaysia, road design and incident in Malaysia. His team in 2022 studied accident in Kajang, Malaysia. They looked at how road shape like curve, slope and junction affect the crashes. They found that road design is a big reason why accidents happen. They use map to find dangerous spots and said better road planning can help keep people safe. And the third one is finding accident hotspot on roads. This research in 2019 used a smart map method called NKDE, which is network kernel density estimation, to find exactly where accident happens on roads. It works better than old method by showing small danger spots instead of big general areas. This helps fix problem in the right places. And the fourth one, better way to find crash area in London by optimizing KDE bandwidth for hazard detection. Zhang and the others of his team member in 2024 worked on finding the best way to spot where crashes happen in London. They use a special search size which is 134 meters to find accident clusters. Their method found both small and big danger zone and give better result for planning safer route. And lastly is spatial and temporal GIS analysis of crashes in Nepal. Billy Dugana and his team member in 2024 used map and police data to study road crashes in Nepal. They found many accidents in main highways and during rush hour. Most crashes involve motorbikes and big vehicles. Their work show how maps can help plan better and make roads safer.
Now I will explain the methodology used in this study, which is divided into 4 main stages. First, we collect data based on vehicle type, time and weather. To support spatial accuracy, we use a base map that provided in ArcGIS Pro. Next, the data was processed by classifying according to vehicle types, such as car, motorcycle and lorry. We also classified the time of day using shapes circle for bright hours and square for dark hours. Weather conditions were simplified as R for rain and H for hot weather. To analyze vehicle density, we apply the kernel density estimation method. This helps us identify areas with high concentration of vehicle activity. Using the process data, we create 3 heat maps, one for each vehicle type. We also overlay time and weather symbols to add context. All this was combined into one final map output. Finally, we publish the complete map using ArcGIS dashboard. This allows for online interaction and public viewing, making the data more accessible and dynamic. This methodology gave us a clear way to visualize and understand vehicle movement pattern. Let's move on to the result.
Next, result and analysis. For this map of road accident risk monitoring and mapping, focusing on 3 key parameters, which is types of vehicle, weather and time. We use geospatial information system to map and understand where and when road accident happen. Also, what kind of conditions are involved. This help us identify high-risk area and the factors contributing to the accident. For the map element of accident point, each point represents a reported accident. The symbols and colors show specific conditions, which is blue for daytime and hot, green for daytime and rainy, yellow for nighttime and hot, and lastly red for nighttime and rainy. For the risk zone, the background colors shows accident risk level, calculated using a geospatial technique called kernel density estimation. It shows yellow areas have low risk, orange means moderate risk area, and red highlights high risk zone where accident happen most often. The first parameter used, which is types of vehicle, although not visually differentiate on this map, the underlying GIS data includes the types of vehicle involved in each accident, such as cars, motorcycle, and trucks. This parameter let us analyze which vehicle types are most frequently involved in accident at different locations and time. Then, weather parameter. Weather conditions are shown by the color of each accident point. Blue and yellow represent hot weather, while the green and red represent rainy weather. This helps us see the impact of weather on accident frequency. Lastly, time parameter. Time is categorized as day or night, indicates by the color coding. This allows us to identify whether accidents are more common during the day or at night. As for spatial analysis with geospatial information system, we use kernel density estimation as it calculates the density of accidents, highlighting hotspots where accidents are more frequent. These are shown as red zones on the map. By overlaying accident data, GIS reveals clusters such as the high-risk areas around Kuala Lumpur and Petaling Jaya.
This map shows the accident risk level using 3 colors. Yellow means low risk, orange means is moderate risk, and red show the high risk area. As we can see, high risk area are mostly found near Kuala Lumpur, Shah Alam, Petaling Jaya and Klang. These are very busy area with a lot of traffic, which increase the accident chances. On the left, we can see the total number of accidents by vehicle type. Car was the highest number. The pie chart on the right showed when and during what weather most accident happen. Most accident happen during the daytime, 58.70% compared to night, 41.83%. And more accident occurred during rainy weather, 8.16% compared to hot weather, 31.84%. Accidents are more likely to happen during a day and when it's raining, especially in high traffic area. This information can help us plan better safety measures for those high risk zones.
To conclude, this project has shown how geospatial tools like GIS and kernel density estimation can be effectively used to monitor and map accident risk in Petaling, Selangor.
By analyzing key factors such as vehicle type, time of accident, and weather conditions, we were able to produce a detailed risk map that highlights specific high-risk areas. The data revealed that most accidents occur during the daytime and under rainy weather, particularly along major urban routes. This spatial insight is crucial for improving road safety. It allows authorities and planners to take targeted action, whether through better infrastructure, increased enforcement, or public awareness campaigns. Overall, this study proved that accident risk mapping is not just about identifying danger zones, it's about providing the right information to the right people at the right time so that life can be safe and risk reduced.